Hello and welcome to this Antenna Lab tutorial. In this tutorial, we're going to be discussing how to view and format results in CST. So first, we're going to start with animated electric fields. So I have this same antenna that we've been talking about in our research, this double slot antenna. We want to export the electric fields. So this is a 3D rendering of the electric field pattern for this antenna embedded in muscle. So if we go to 2D, 3D plot, there are a couple things. Let's actually start from the beginning, I'm taking advantage here. So let's come back out here to 2D results. We're looking at the absolute value of the electric field. How did I get it to look like that? So number one, in my case, I'm looking at cross-section A of the fields. So if we did like cross-section B, we would see these weird cross-sectional views. We just want to stick with A, so we'll get rid of B. Okay. The other thing we can do is adjust the scale. So in this menu, you can just adjust the maximum. If you want to do anything fancier than that, you'll come to here. Oops. Come to color ramp. You can change the color like so. We're just going to leave it. And this ticked count is the number of divisions. So like right now I have it set at 20, the maximum is 1,000, so there will be 20 divisions between 0 and 1,000. And so whatever you do when you're exporting all of your results, you want a standard basis for comparison, right? So it doesn't matter what it is, but pick a scale. So in my case, I really wanted to accentuate the field pattern, and so I set a maximum of 1,000 volts per meter and 20 tick marks. So whatever scale you want is fine, just pick it and stick with it so that all of your results can be compared to one another. So now we've formatted our scale here. I particularly want to accentuate the fields at the end of this antenna, so I'm going to zoom in. Alright, so here's what we're going to be recording now that we've zoomed in. We're going to record this action of the fields propagating. This is a function of phase. In order to export this as a video, we need to first stop the animation, and then we will go to Home, Macros, Reports and Graphic, and I want to save this video. So ideally you should name this. I'm not going to. And it gives you, again, you can customize this however you want. I find that this step size is reasonable, so I really don't customize any of this. I just go ahead and run it, and it will take a moment to render. Okay, welcome back. So we've generated our video. You will get a couple messages if we look down here in the right hand corner. It'll notify you that it started generating the movie, or GIF in this case, finished generating the movie, and then you're going to get this complaint, which is that it will automatically try to open the GIF right after you've created it, and it doesn't have a default app installed. So this doesn't mean that it failed, it just means that it can't open. And we have the file down here. So if we come over here to this SP folder, we have it right there. Alright, so the second result we're interested in Microwave Studio is typically the S parameters, which is found in the 1D results folder. In this case, we just have S11 for our antenna. So these are results for S11 in dB. In my previous video, I talked about this notion of a resonant frequency, which corresponds to where it's the most negative, or where the linear value is the smallest. So Remember, S parameter is a way of representing the reflection coefficient. Here we have the magnitude of the reflection coefficient, so the magnitude of the real and imaginary components. We desire, in a perfect case, it would be 0. That would be perfectly no reflections. It would be perfectly matched. So in a linear case, we can see the smallest value here is at 0.2. If we look at that in dB, the most negative number here is -14. So we would say that our resonant frequency is somewhere between 1 and 1.5 gigahertz. This isn't ideal for us. We had wanted it to be at 2.45 gigahertz, right around here. So we're going to have to optimize. But for now, we can just capture these results. The easiest way to capture these results is to use snip. And just take a capture of this screen here. Like that. In the future, when we're looking to formalize our results, we will, here, let me not talk, and multitasking is not exactly my forte. Anyway, when we formalize our results, rather than just doing experimental results, we can come down here and copy these results and put them in an Excel file. And then we will plot this in something more formal like MATLAB or Python. And so here is what that looks like. So here is the results of our S parameters. This is the frequency, the real and imaginary component, and then this is the reference impedance. So, or excuse me, the characteristic impedance of the antenna. So it's calculated the characteristic impedance antenna right around 50 ohms. Okay, so we have captured the electric field and we've captured S parameters. One other thing that might be useful is, I of course already showed you how to look at this on a linear scale. The other thing that is worthwhile is looking at the Smith chart. Before we do that, it can be worthwhile to put a curve at your frequency of interest before you look at the Smith chart, because when you go to the Smith chart, where your frequency of interest isn't particularly meaningful here. So the way that we can add curves is, first, let's say we want to set a marker right at this resonant frequency. We can probably just eyeball that. But if we wanted to be particularly precise, we could zoom in, just click and drag, and then we can put it right around this resonant frequency. So it's resonant around 1.2 gigahertz. And then you can hit the space bar to zoom back out, and let's put a curve marker at our desired frequency, 2.45 gigahertz. So we can add another curve marker and just double click to place, zoom back out, and then we can go over and look at the Smith chart. And now we can see our markers in terms of where the impedance falls for our for our desired frequency. So we can see these both fall on the positive side of the Smith chart. So we could say that both of these frequencies, the antenna behaves inductively. This isn't particularly ideal, but we at least get to see how to view the results. So that covers everything of interest for electrical results. Thanks so much for watching.